What's up, math scholars? Mrs. Harp here. We're going to learn about some box and whisker plots. Raise your hand if you've ever seen a box and whisker plot. Kind of looks like this. You got a whisker, you got a box in the middle, and you got another whisker. And the whiskers might be different lengths, it depends. So raise your hand one last time if you've seen them before. That's almost everybody. So who's excited to learn about them and probably just remember about them since you've learned before? You excited? Yeah! Woo! Do you remember anything about them? Like what this guy is? This is the most important guy. He's the median. So you really can't tell anybody what the mode is from a box and whisker plot. And you can't tell anybody what the mean is. But you could tell somebody what the median is. You know what else you could tell somebody from box and whisker plot? The range. Perfect. Because this would be the smallest number. This would be the largest number. And you could subtract them. Yep. So this is just a cute rendition of a box and whisker plot we found on the internet. It makes it look like a cat, but actual box and whisker plots don't have ears or eyes or anything like that. Box and whisker plot organizes data into 4 groups. You've got this whisker down here. This would be basically extending down to the lowest data point. You have this whisker up here. This would be extending up to the highest data point. You have your median in the center. Maybe I could just label some of this. So this would be the lowest data point. This would be the highest data point. This would be the median, which is in the center. Now, once you find your median, you split your data into like an upper group and a lower group. And then the median of the lower group is called the lower quartile. It's a fancy word, but it's nothing more than a median of the lower data set. And then the same thing here. It's another median. It's the median of the upper data set. It's called the upper quartile. Says the ordered data are divided into lower and upper halves by the median. The median of the lower half is the lower quartile, and the median of the upper half is the upper quartile. So there's a lot of information here. Maybe you could just draw the picture and label everything and not write down what I have written on the bottom. Something I do want to point out is how much of the data would be in the different places. In every section of the 4 sections, it would represent 25% of the data. It's like this whisker down here would be 25% of the data points. This half of the box would be 25% of the data points. This half of the box, another 25% of the data. And then this whisker up here, 25% of the data. That's something very important to know. Alright, we're going to make our own box and whisker plot now. So our first job would be to find the median. So are the numbers already in order for us? We have to reorder them.
Yes.
They're already in order, so we're going to go ahead and find our medians. We're going to count to the center. 2 and 32, 7 and 22, 12 and 18, 17. This is the median. That would be the absolute center of the box. So you get to number your number line however in the world you want. You probably want to make sure you can go all the way down to 2 and all the way up to 33. You want to number, how do you guys want to number it? Totally up to you. My last class numbered by 4s, and that got a bit confusing. So what do you guys want to do?
2s.
Number by 2s? I think I'm going to need more hash marks if I'm going to number by 2s. We'll do 2s. That's fine. I'm going to get rid of this one and just draw 2s, okay? So Gabe has spoken, and we're numbering by 2s. Here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. That'll be plenty. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. We're numbering by 2s. I left the 4 off. Okay, So let's draw our whisker. So we'll have a whisker all the way down to 2. We'll have a whisker all the way up at 33. I'm actually not going to draw the whiskers yet. I've got my middle of my box going to live at 17. Now what I've done with my data set is create a lower data set down here and created an upper data set up here. You don't include the 17 in either the upper or the lower. You can kind of remove it. You're going to find the median of the lower data set. What would that be? What is the middle number in my lower data set? 7. That'll be where my lower quartile is. It's called the lower quartile. So you'll put a line there. That'll be the lower half of the box. Then you'll find your upper median. It's called your upper quartile. What would that number be? 22. You're going to put a line there, and that's going to make this box. And then your whiskers will go out to the 33 and down to the 2. That's it. Does that bring you back memories? Pretty easy stuff. Not bad at all. Okay. I think the next one we just get to look at some already made box and whisker plots and answer some questions. So this is box and whisker plots that have already been made representing rainfall in Dallas in blue and Houston in green. We're going to get asked some questions. It says, for how many months is Houston's precipitation less than 3.5? So we're going to go to Houston, which is the green box and whisker plot. I'm going to find 3.5, which is here. So basically this right here that I'm highlighting, maybe I should write on it for people watching the video. This stuff right here would be where they're getting less than 3.5 inches. So what percentage of the time are they getting less than 3.5 inches? What do you think? What percentage of the time? Like 50% of the time? 75% of the time? I'm making a multiple choice test. 25% of the time? What do you guys think? Yeah? Good! Ding, ding, ding! You get a ticket! I was afraid I was going to have to pause the video and, like, yell at you guys for not participating. Alright. Alexa, save the day. Basically, 25% of the time, they are getting less than 3.5 inches. Now, the question is, for how many months? So what you're going to do is take 12 months, multiply it by 0.25, and that'll be how much 25% of the year is. What's 12 times 0.25? 3. So for 3 months, they're getting less than 3.5 inches. All right, it says compare the precipitation in Dallas with the precipitation in Houston. So here's Dallas, here's Houston. It looks like Dallas has a much larger range than Houston. And it has a much lower median than Houston, so you can just like list things like that out. So Dallas has a larger range, but smaller median amount of precipitation. It says, how many months was the precipitation in Dallas more than 2.6? We get to do that how many months thing again. So we're in Dallas. We're at 2.6, which is right here. We want it to be greater than 2.6. So what percent of the months did I just put in my green box? 25%, 50%, 75%? What do you guys think? 50%. And so that'd be 6 months. So that was kind of nice. They already had the box and whiskers made. We just had to kind of interpret them. All right, we got a couple multiple choices here. About what percent of the data is greater than 20? Here's 20. What percent is greater than 20? Perfect. What percent of the data is less than 15? Here's the 15. 50, perfect. And then what did they do wrong here? They are saying that 25% of the data is between 11 and 20. Here's 11, here's 20. What did you say? So to change it, let's change this number. What could I say? Good. Yep. So about 50% of the data is between 11 and 20. Right? Ooh. Make sure I'm not. Yep, we are still recording live. Okay. Alright, so this is going to talk about a couple new vocabulary words that I have not mentioned yet to you. Let me draw myself a quick box and whisker plot so I can show you something about interquartile range. Alright, so this is a box and whisker plot I made with a really, really, really long whisker, and I did that on purpose. Basically what you can find is something called the interquartile range. The interquartile range would be the difference between the lower quartile, which is this guy, and the upper quartile, which is this guy. And they call that the IQR, interquartile range. Now, the interquartile range can be used to figure out if one of your data points is a true outlier. Up until now, we just kind of estimated outliers, and we were like, yeah, that number doesn't quite go with the rest. He must be an outlier. Well, there's an actual mathematical way of finding if something's an outlier. So I'm just going to make pretend data here. Let's pretend this is the number 1. This is the number 20. This is the number 25. And this is the number 30. So 1 does seem like he's way back down there, right? But here's how you can figure out mathematically if 1 is an outlier. So you'll find the interquartile range. How far is 25 from 20? 5 units, right? That makes my interquartile range, my IQR, equal to 5. What they're going to do is they're going to take the interquartile range, multiply it by 1.5. So let me grab my calculator. We're going to do 5 times 1.5. That's going to give you 7.5. Now, if this number is more than 7.5 away from the lower quartile, then it is an outlier. And it is. Since 5 times 1.5 was 7.5, and we are way beyond that as far as our distance away, that makes 1 an outlier. Okay? I'll pause this and let you write a while. Alright, we're on our last example problem. They're basically asking us if the 75 is an outlier. So we have to kind of find our IQR, our interquartile range. So we better find our medians and all our quartiles first. We don't have to actually make the box and whisker plot if we just find all those quartiles. Is my data in order? First things first. You don't want to find a median unless your data's in order. So our data's in order. Let's go ahead and find the median of the whole entire thing by counting in 75 and 2, 28 and 15, 28 and 17, 18, 22, and 19. So 19 is our median. Sound good to everybody? That separates us into a lower group and an upper group. What's the median of this lower group? 16. It's not an actual number on the charts. That's called the lower quartile. What's the median of this upper group? 28. Sound okay? That's the upper quartile. So to find the interquartile range, you simply do the 28 minus the 16. What is 28 minus 16? 12. Good. So we have to take the 12, multiply it by 1.5. What's that going to end up being? 18. Yeah. And so we want to say, is 75 more than 18 units above the 28? Because that would be making the box. The 3 numbers that would make our box would be 28, 19, and 16. Is that more than 18 units away? Yeah, so I'd say 75 is definitely an outlier. Now what about 2? Is 2 more than 18 units away from 16? No, so 2 is not an outlier. Okay, so you follow how you do that? Find your interquartile range, multiply by 1.5, and see if you are a further distance than that away. Okay, I'm going to go ahead and stop the video. Thanks for watching if you watched today. The homework is a 10-5 worksheet that I'll be passing out to the class.